All right. So everyone, inshallah, today we'll be introducing the AirMod, the air dispersion modeling software. You remember last week we talked about the concentration models. And the concentration models, we had two models, which were Ahmed, which were ما شاء الله كلكم عملتوا assignment. What were they called? The diffusion model and they are all the concentration. Fixed box model. So what we will focus on today is the application of the diffusion model. I told you that this diffusion model is the model that's actually used, okay, that's actually used for compliance. So this model is being used in government, in consulting, in actual word applications everywhere. Okay, so to show compliance with the local regulations. The model itself is being developed by the US EPA, the US Environmental Protection Agency. The model is called AirMod. AER, as you can see it here, AERMOD. That's the name of the model. Now, does the EPA, do they generate a computer application? No. What they actually, the EPA do is a code, a source code, program. So they give you a code that you can use. Who knows what DOS is? MS-DOS. You know DOS, the application, when the black screen and keeps blinking, and then you write commands, CD, whatever. So the AirMod is a program that you can run from the DOS shell, which you write your input on a file, on a text file, and you put it in the same folder, you run the software, it gives you an output file, and you try to understand what it is. Very complicated. So what happens is commercial companies, they went in and did something called GUI. GUI is short for GUI, which is graphical user interface. Graphical user interface. So basically, they take the source code that's being developed by the EPA, and they make a computer program output that runs the EPA code in the background, but it gives you the ability to draw things and have colors and see the output in contours and so on. So again, it is a government-developed software, but inside a commercial package. You understand? So there are three main companies that do this graphical user interface. One company in America, one country in Canada, and one country in Brazil. These are the three countries that sell everywhere in the world. The two biggest ones are the one in America and the one in Canada. The one we will use today is the Lakes software. And this is developed by the Canadian company. The one developed in America, it's called Breeze. And it's also clever for breathe. So, but it's different. It's different writing. Okay, so the AirMod view now is the software that I will demonstrate for you today, and inshallah, you will use in your lab by yourself. So if you open the software, it will look like this. Just a blank screen. I will open one of the files that I actually have done earlier. So just to show you the end of it. So this file belongs to the Sharjah Municipal Wastewater Treatment Plant. So it's the wastewater plant in Sharjah city. and this is what it looks like. So if you look closely here, so if you can look closely here, let's zoom in. This is one of the main intersections in Sharjah. And if you can spot a wastewater treatment plant, you will see that here there is all the tanks for the wastewater, all of this. Now, can somebody tell me why we are interested in modeling concentrations around wastewater treatment plant? What kind of pollutants? What are the pollutants that are expected from a wastewater treatment plant? Not really that problem. Not really sulfur. You are close. Not SO2, but the other sulfur. Sulfate is SO2. Sulfide. Sulfide. H2S. Do you know what is sulfide? No. So, do you know what sulfide is known for? Bad smell. So actually, all the bad smell, not all, but most of the bad smell that comes from wastewater is coming from the hydrogen sulfide. So we do regularly model new installations or new projects in wastewater treatment to see how it will affect the area around. Because you don't want to be in your car driving here on this intersection and start to smell coming from the wastewater treatment plant, correct? Look at the stadium here. We don't want to be cheering for a team and the smell starts to attack you while you are there. And more than you think, there would be somebody VIP very important that's living around this. And whenever they call, everything is really changed the least we can say. So now you were asking, Muhammad, what are these contours? I can tell you these are the contours of the concentration. Now, how did we get there? How did we get to this plant over here? Let's see. First, when we start a new model, we choose the model type that we will use. We'll have AirMod, ISC T3, and ISC Prime. These are older models, still can be used, but not the latest model developed by the EPA. So we want to choose the AirMod model. So you start by putting the coordinates for the site. Why does it matter that we put the exact coordinates? Because if we put this plant in Al Ain or we put it in Europe, it completely makes a very big difference because of a lot of things. Wind patterns, solar light, meteorology. Remember all the things that we said they do make a change in the model, but also because of elevation. Now remember when we were saying that if the air is going or the wind is going in one direction and they found the mountain, we cannot just model that it's going through the mountain, but it has to go up and round and so on. So having the exact location makes a really big difference. So the very first thing that we do in a model is to establish the coordinates in the model. And in this case, what Google Earth is your friend. Google Earth is where you go exactly to your site, look the exact coordinates, because you can see, I want this tank. So you can really get the coordinates of this tank to the millimeters, the right coordinates. Then you can go into the map projection. So now when I put the right coordinates, I can actually import the map. So this map that you see right now that has Salaam alaikum Said. So this map that you see here is actually imported based on the coordinates that I gave to the program. So when you start, it's not that the whole planet is there similar to Google Earth, and then I choose where I'm going. But actually, it's a blank screen. And when I give it, and then I say, okay, import the maps that actually correspond to this particular coordinates, then I get, if I do it wrong, I will get something in China or wherever. These are the things that overlay layers on my program that I can get. Here is in import options to get base maps, tile maps. This is where we can get such a map to overlay. So we go here through this menus, from control to source to receptor to metrology to output. If we go this one by one after we put the coordinates, the right coordinates, we can see exactly what does this model need to run. So first is the control options. We get the dispersion option. You can run with the default pollutant. As I was telling you, here we are looking at H2S, but it could be other pollutants from the menu: SO2, CO, NOx, total suspended particles, PM2.5, PM10, and so on. H2S belongs to the others, and then we need to choose what are our averaging time. Remember the averaging time? Where did we cover that? In which class? Max. Very good. Very good. And then we need to see that if it's period, month, annual, and then you have to choose your dispersion coefficient. Is it urban or rural? Why does it make a difference? The amount of people. The amount of people actually will come and we'll have to write an estimate. But there is something called the urban island heat effect. For example, think about New York City or Dubai. If Dubai was the same land without the buildings, the weather patterns will be completely different than Dubai with the high-rise towers. And this is what we call urban island effect, because when you start getting a lot of urbanization, a lot of very tall buildings, the heat gets trapped inside between these very high buildings, as if you are building a fence. And it gets hotter and hotter. Okay, so that's why urban versus rural makes a very big difference in model. Next are terrain options. You can see that from this, you have here the stack height, stack base, flat terrain, elevated terrain, complex terrain. And here are the options where you can tell the model where you are. Is it flat land? Most of UE is flat. So when we are doing UE, we'd mostly say flat unless really your factory or whatever you are modeling is on Jebel Jais, for example. Then we need to look for something. If we are in Oman, probably will not use the same one. Then we'll have to go for the complex terrain. Next, we have some options. If we choose NOx, NOx has some properties where there is photochemistry involved that can do a more reaction that goes NOx to NO2 and so on. So NOx chemistry is a little bit complicated. So there are options. If we choose our pollutant to be NOx, then we'll have more options, as well as ozone. Ozone also has its own menu. So moving to the next, after the control, you will have your sources. So this is where you start to input your sources of pollution. What are the sources of our pollutants? Usually, it is point source, which is a stack. That's the most easiest type of sources. Stack, and that's a point. So, for example, here, we have scrubber. You know now what a scrubber is hopefully from the new chapter. We have bi-trickling filter, we'll learn about them, but these are all sources, all point sources. Basically, they have a specific coordinate where I can say this is where the emissions is going out. And again, I have to get the coordinates very, very specific from Google Earth. Okay? Also, other types, we have area sources and volume sources. Can you think about an area source? What would be an area source of pollution? What could be an area source of pollution? Any idea? A landfill, so a big area that it's all uniformly emitting at the same time. So not a point like a stack, but an area that's emitting. Can you see here? This tank, for example, is an area source because you see where I'm pointing? Ya Abdullah? Ya Abdullah, I want. You see where I'm pointing, please? You see this, for example, this tank is an open tank. So now all of this is emitting at the same time. So I cannot say this is a stack, but this is an area that's emitting. So this is the definition of the area source. Can you think of a volume source? اديني volume source يا احمد. شكلك you have something. No? Okay. Volume source. For example, the gas station. Gas station is a very good example for a volume source. You cannot just say where I am putting the gasoline in the car is the emission point, because you can never go into that specific point. But you can say the whole gas station is emitting whole, from up, from down, from the sides, all of it, and that's an approximation for sure, but all of it is emitting uniform emissions. And then it becomes an volume source. Yes, yeah. Definitely. It's very hazardous. So always there are two, and that's very good, actually. It's really a very good question. Always there are two regulations that govern air pollution. There is the normal one that we talked about in this class. For example, what NAAQS is involved. And when you are doing modeling, usually you're trying to get the NAAQS. So that's the most obvious one. The other one is the one for the occupational health and safety. And this is covered for the people who are in the plant. Usually that's more stringent, meaning like it's more difficult, but for the short distance, not on the long distance. Okay. So in America, there are two bodies. You remember the EPA? I keep saying the EPA is the one that makes sure that we have the NAAQS, everything is good. That's the EPA. What is the other one?
Canada. The one who said about Canada.
ده السوفت وير يا محمد ما تدخلش الدنيا في بعض. So EPA does the main thing. What is inside? That's the CDC, the Center for Disease Control. They have this occupational health and safety inside, and they give you workers cannot be exposed to this pollutant for more than this on the short term and more than this on the long term. Okay. You remember in Corona, they were the ones that came out, and Fauci, that was the alhamdulillah. Okay, so these are your sources. After the sources, and this is one of the most important things in a model, right? To write what are your sources. Next will be your building downwash. Now you remember when we talked about the model, and I told you if you have big buildings around your stack, they will cause all the patterns to be different. So the air patterns will all change based on the buildings around. So we do, in the model, we do draw buildings and we give it its elevation, and then we run a model, a separate model called the building downwash model, to see how the buildings will affect the smoke coming from our source. And then finally, the background concentration. Remember, this is the B that used to be in the other model, in the box model. Remember the B, C is equal to B plus. So this is the B. What is the background concentration? For example, here we are doing a new scrubber in this wastewater treatment plant. But not all the new odors are coming from this scrubber. There are already a lot of odors coming from the wastewater treatment plant itself. So I need to know what was the baseline background and what am I adding. So this is what was there before my project. All right. Now, for the sources, we have options. These are the groups. So, for example, I have different scenarios. Now I have 3 new units. I'm saying I will use the 3 together. Or before the 3 were built, after the 3, just one individual. So these are the groupings. So we group them in different forms just to see their impact. Now, variable emissions, if the emissions themselves are changing. So for example, is it always the same coming out of the stack, or is it changing? Let's think about this tank. Now, this tank that has water and the emissions are coming, the odors are coming out of the tank. Do you think in the summer we'll get the same like the winter? Definitely not. With the temperature, you will get more activity, you will get more smell, right? So the even by season is different. Could be by day and night, it's different. If it's a factory operating in the morning, not operating in the evening, so in the morning you have emissions, in the evening you don't have emissions, and so on. So this is variable emissions. Yes. It depends on the operations. Maybe the factory closes at night, so they don't have emissions. Maybe they operate just with a minimum shift, so there will be emissions, but it's much less. Then at the evening, the emissions will be 0. No, maybe it's the other way around. They don't work in the morning; they only work the night shift. So in the morning is 0, in the evening is 0. If it's not working, where will you get emissions? Right? No, what stays in the air stays in the air. But we are looking now what's being emitted. Okay. Next. Is the receptor menu. You see this? This is the receptor menu. What is a receptor? Receptor comes from receiving. Receiving. So now I put the sources, what's being emitted, and now I'm putting where am I receiving. So remember when we started this class, I always told you, and I keep pointing over there. I tell you this: the stack is in this building. Now what are we smelling over here? So now this is the source. We are the receptor. This is basically what it is. The receptor is where we are calculating the concentration. So In order to do that, we do something called a grid. A grid could be a uniform Cartesian grid, which is you take your area and you put lines, vertical lines, horizontal lines, and then every intersection, that will be your grid. And then I calculate at every point. Or it could be a polar grid, meaning that from the point where it's being emitted, I make circles, bigger circles, and then lines, I divide the 360 degrees with lines. And then the intersections will be my grid points where it could be 1 point. For example, I have a very important VIP, and I want to make sure that at this palace, there is no emission. Just 1 point. Could be a hospital or a nursing home. Okay, so this is what a receptor means. So grids, what I told you, could be uniform Cartesian, non-uniform Cartesian. So basically, in one direction is different than the other direction, the X different than the Y. Uniform polar, circles, concentric circles with the same radius, or non-uniform polar. So basically, it starts with smaller circles, and then as we go away, it gets bigger and bigger, which makes a lot of sense, by the way. You really care about the plant because that's the highest concentration. And the more and more you get away from the plant, going 2 kilometers to 2.2 kilometers doesn't really matter. But going 200 meters just close to the plant makes a very big difference. You get the point? So I'm saying that when you are close to the source, every meter matters. Every meter matters. This meter is different than this meter than this meter. But if you are really far away from the plant, 3 kilometers away, you can go to 200 meters without really big changes. So you want your grid to be very close next to the source, and it can be further apart away from the source. Making sense? Of course, alhamdulillah. Discrete receptors, this is what the points that I was telling you about, that if we have a specific point, discrete point, that we want to test at this particular point. Fence line is the fence line of your facility. For example, if this university is the source, I need to know what is the fence of the university, because inside the university is something, and outside of the university is something else. Outside is what we call ambient air, which is the air where the NACS really applies. Inside the facility, remember the difference between the EPA and the CDC? Inside the facility does not belong to the NACS. Then it becomes different rules. And the ambient يعني خارج. So ده الهواء الخارجي. Ambient air الهواء الخارجي. We do the fence line in order the regulations only apply in the ambient air, outside your fence line. All right, next menu. Which is the meteorological menu, this one. See, the one with the sun and the clouds. This one is where we put our input files. So the model is actually much more complicated than you think. So it's not really just one model that solves this equation that I've covered for you in the class. But actually, there is 2 types of meteorological models that run in the background. And then one model for land, for elevations, and one model for land use. And all of them work in parallel together with the model that we use in the class. Long story short, you need to put input for meteorology. You need to put input for land use, land cover, and elevations. These are all that you get from databases that are available worldwide, some of them specific to to UAE, some of them we can only get from America. Okay? Any questions? Next menu is the output. Here is, we tell what are the outputs that we want. For example, you want the first highest value for all times and 1 hour average. You remember in the next table, we had this different like conditions for criteria for threshold. This is what gives you that. So the model can tell you, okay, after I run everything, this is the highest, or this is the second highest, the fifth highest. If it's average on 1 hour, if it's average on 1 month, if it's average on all the period that we run the analysis on. Now, when we, and I'm sorry, I forgot to tell that. When we put the input file, I want just to, if I'll try to show you the input file. For example, this is the input file for weather data. You see, it's something that's really you don't understand. So, and keeps going. I'm just now scrolling down this. It keeps going and going. This covers 5 years of data. 5 years of data for every hour in this 5 years. فما تخلص بالظبط. That's why it's prohibitive. You do this by hand. You can do it. You can do as a check, but you cannot really run something that will help you. I'm sorry? It's a very good question. Which period? You might as well use the most recent available 5 years. So let's say if we don't have 2024 data yet, because now we're in October, so we will use until 2023 from 2018. So 2018 to 2023. When I want to model something, when I modeled this, that was last year, I used, I think, 2018 to 2022. That you use the last available 5 years. But what if the last year also was not available? You go 1 year before.
How much time we use that every hour?
Yes.
Must be every hour.
Yes. And there, no, you cannot. You can, but then it will not be accurate, because really the wind is changing every minute, even not every hour. So that's why you try as much as possible to be accurate. So weather stations, they do measure every hour and they do report. So the only problem is just to get this data. That's the basic. Now, we have here 2 files, which is the surface meteorological data and the profile meteorological data. So let me show you how this meteorological data looks like. See this wind rows? This is what you get out of this text file that you've seen that doesn't end. This gives you an indication where are the winds that are happening in Sharjah. This is based on Sharjah Airport. In the last 5 years from Sharjah Airport, from 1/1/2017 to 12/31/2021. Seventeen. 1/1/17 to 12/31/2021.
Because 12/31 is last day of 2020.
Last day, from 1st of January till last of December. 5 years exactly. And this comes from the Sharjah Airport. What does this mean? North, west, east, south. This is, if you are in Sharjah looking north, what is north of Sharjah? لا شارجة
والله ما ركز.
Sharjah itself not the plant. What is north of Sharjah? ايه يا جماعة؟ بلدكم خير.
انا عيب ما اعرفك ما اعرف شو.
لا حول ولا قوة إلا بالله. لا احنا كده هنرجع I will send you back to high school. ايه north of Sharjah؟
لو جروب هون ممكن مشكله الشارع فاهم يقول
لا north of Sharjah.
نسيت
ده سيد. ايه يا جماعة؟ ما بقى.
شفت الدكتور استاهل.
لا دي بونس ايه بس؟ لا ما يصحش كده. ما يصحش. طب west of Sharjah. دبي. east of Sharjah. عجمان. south of Sharjah. يعني العين يعني ماشي. لا much more east. Okay, so what does this mean now? This means you see how the largest here is this direction. This means that most of the wind is coming this way in the most time of the year, and it has the highest velocity. So this is the frequency and the colors are the velocity. This tells you the direction and the magnitude and the frequency of the wind at this particular station. So out of this, you can tell that either your winds are coming from Saudi Arabia or they're coming from Oman. Saudi Arabia, Oman. لكن دروس جغرافيا شوية. North is the sea. Where it's coming from? النهارده ازاي بس؟ يا عبد الله. حاضر انا مش هتكلم في السياسه. Producing a own wind. ماشي. اوكي. You put your own model. لا, you can. If we are doing this in Abu Dhabi, we always look for the closest airport because usually the airports have a weather station. Wherever there is, يعني I have modeled مثلا in Palm Jumeirah. The model in Palm Jumeirah I used Dubai airport. والعين we have airport. It really depends where you are doing the model. This is an approximation. The best thing is to put your station at your site, because even the wind changes between when you are going from the airport to this wastewater treatment plant. The wind is different, but it's an approximation. لأن you cannot just put a meteorological station for 5 years waiting for the data and then you will get the data to use the model. Doesn't really make sense. Yeah, اتفضل. لا, that's not the project. That's just a lab. نعم. إن شاء الله. إن شاء الله. That's why I was telling you we're trying to install the software in the lab, inshallah, to give you access for it. Next is the terrain. Remember when I told you mountains, hilly, flat. So here we enter the map of where we are looking for, here the whole UAE or Sharjah or whatever, and we put it so the software processes it and puts it on a file that can use for running the model. Again, not very straightforward. Okay, it's a little bit complicated. بص, if you ask AI to do it, why would I hire Abdullah as a graduate of UAE Civil Engineering program than Muhammad that didn't finish high school? He can also run AI and tell them, please run a model for me that does this. Because you can speak English and the others don't.
They don't understand it. Like you will understand, but you will be easier to learn.
ماشي يا عبد الله. Okay. Not good questions. And then you have options on how to get the contours and how to for the outcome and how the coloring and the rules and the terrain and so on. And then you have your reports, you have your 3D view. So let's look at the 3D view here. Take some time with the 3D view, just stopped working anyways. So we'll stop here today, and inshallah on Wednesday we'll go to the computer lab. I'll send you an email exactly once I just make sure that it's all installed, and then we'll do it together on the computer at the same time. Okay, I'll put this recording on Blackboard, so also you can get back to it inshallah.